Check. Check one.
Dang it.
Check. Check one. Check. Check. Check one. Check. Check one. Check. Check one. check. check, check, check one, check, check one, check one, check, check one, check two, check, check, check one, check.
Check. Check. Can you hear me clearly? Last rows. Pay attention, everyone. Pay attention now. And online students, hope you can hear me clearly. Students in the live and the Zoom, hope both can hear me clearly. So yeah, let's start with the session. Last rows, can you hear me clearly? Last rows. Okay, thank you. Be seated, everyone, quickly. Hope online students got the tunes by now. If like you have the drive links given, there you can find the tunes. In the drive links, you can find the tunes, but ideally we delivered like close to 1,000 tunes. So like at least 90% of the online students must have received the tunes by now, okay? Clear? We delivered close to 1,000 tunes, so at least 90% of the online students, we hope you have the tune with yourself, okay? But still, if there's any online student who didn't get the tune, you will receive them within like 2 days, okay? You will receive them like at least within 2 days. If not, like, you know what to do, okay? Put a message to the hotline or put a message to the Zoom chat, okay? Let's wait a little, like, till the physical class is getting settled. Oh, you got 2 tunes. There's a drive link. If you didn't get the tune, there's a drive link available. Oh, a lot of students have got 2 tunes. You got an optics tune too. Yes, we send that in case you join the fast track. I'll explain that. I think you guys also got the optics tune, right? Yes, right? Did you get the optics tune? Okay, it's because I mean, in case if you join the fast track program. Okay, we are going to start optics soon as a part of the fast track program. So the optics tunes were sent just in case if you join the fast track. Okay, so it's not mandatory. Any problems, online students? Any problems until now? When is the fast track? Within 2 weeks, I'm starting optics. I'm starting optics within 2 weeks, okay, as a part of the fast track program. Any other questions? Any other questions? No, the optics class would be like 2 hours. Okay, be silent now, everyone. Pay attention. Pay attention, everyone. Let's start the class. So, some concerns, I mean, some students have mentioned different concerns. I'll talk about them. Towards the end of the class, I'll talk about them a lot. But at the beginning, I'll just give you a rough idea about everything. Today, we are starting vectors. Pay attention, everyone, now. Pay attention. Today, we are starting vectors. That means mechanics. Pay attention. Now, stop talking, everyone. Stop talking. Okay. I still can hear people talking. Pay attention. Okay, so today we are starting the vectors. That means the first part of mechanics. From 3 to 6:30. From 3 to 6:30, and from 6:30 to 7:30, you have that usual program where we do difficult questions. But from now onwards, Everyone try to watch that 6:30, 7:30 session. Why? Until now, we did Olympiad kind of math questions in that 6:30, 7:30 session, but from today onwards, we can do things from mechanics and vectors because we are starting them. So even some extremely difficult questions that I put into the tute, I'll discuss in that time, okay? So still the mode of questions in that 6:30, 7:30 session would be same. Questions would be difficult, the explanation rate would be fast, but it would be in syllabus. So the 6:30, 7:30 additional session, now onwards, try to stay in that session. Even though you understand that or not, try to stay in that session. There we discuss extremely difficult questions from mechanics. Sometimes maybe from Olympiad level and all, okay? That is one thing. Then all the online students, we delivered the optics tute too. And for all the physical students, we have given the optics tute too. Why? We are starting a fast track program where we start teaching you a parallel lesson, that is optics, okay? That I'll be starting within like 2 weeks, okay? Pay attention, everyone. I'll be starting that like within 2 weeks, okay? We'll be starting the optics lesson within 2 weeks, but pay attention, that is not mandatory. If you like, you can join the optics session happening this year, but if you think it's too much at this moment, you can join the optics session happening next year, okay? Clear? If you like, you can join the optics session happening now. It's not mandatory. If you think you have time and capacity to finish things fast, yes. Otherwise, you can join the optics session where we start it next week, okay? Clear? That is one thing. Mali. Okay. That's about the optics session. Clear? Then, not this week. I think by next week, I'll provide all the information in the group. We are starting the weekly papers, okay? I mentioned this. We are starting weekly papers. That means every week you will have a paper. We'll give you the marking scheme, discussion and everything, okay? From this week onwards, from next week, okay? We are starting weekly papers. It will be like a 2-hour or 3-hour paper every week. You have to come to the institute or write it online and submit. If you submit it online, we'll mark that online and send it back to you. If you write it at the physical class, we'll just keep them at the institute, okay? Until this program will happen, until we start the main paper class from our side, okay? This program will happen. That is one thing. So those are the main educational related stuff for this week. And next Monday, you know that we have our event from morning 8 to around night 8. I think there's a match going on and a lot of other games. So it's not only for boys and not only for the people who play cricket. There will be a DJ, food and everything, all sort of games. So yes, you can join that too, because I mean, you have nothing useful to do these days, right? So, I mean, yeah, so feel free to join on next Monday, okay? And the ground is at Kotte, not very far away. It is not very far away, so you can easily go there. All the information are provided in the group, okay? Location, time, everything is provided in the group. So try to join. So these are the things for this week. So let's start with the vectors lesson, okay? Okay, and then another factor, like there's a concern about the AC. It has been informed, will be resolved within like 1 or 2 weeks, okay? There's a concern about the AC. I informed that to the institute. So it will be resolved within 1 or 2 weeks, okay? Sorry about that. So let's start the lesson. Pay attention. Vectors. Vectors. So, yeah, if you didn't get the tute, you will receive them, and I'll talk about the tutes later. Now let's start the lesson. Pay attention. Now talking about vectors. Everyone be silent. Be silent, everyone. So, talking about vectors, what are vectors? Here in this topic, what we do is we are actually discussing about different levels. We are actually discussing about different levels of physical quantities. Okay, pay attention. We are talking about different levels of physical quantities. What is the meaning of different levels of physical quantities? That means there are some physical quantities, you knowing the magnitude would be enough. For an example, if someone tells you that the mass of this book is 300 grams, if someone tells you that the mass of this book is 300 grams, that looks like a complete information, right? That looks like a complete information, okay? If we tell that the mass of this book is 300 grams, it seems like a complete information. Nothing else is required, right? Clear? Nothing else is required to understand this information, right? But if I tell you to push this table by 5 meters, if I tell you to push a table by 5 meters, you would ask me another question. What is that? Where or in which direction, right? So push the table in 5 meters is not a complete information, right? Okay, push the table by 5 meters is not a complete information. Clear? It's not going to be a complete information, right? Okay, see? So we have to tell where or in which direction, clear? We have to tell where or in which direction, clear? So that is the idea here, okay? That is the idea here. So here, to understand this, we need two information together. They are the magnitude and the direction. This is our topic today, okay? This is our topic today, but it doesn't stop there, okay? There are some physical quantities that need more information. There are some physical quantities that need like 100 information like this, okay? A simple example, force. Force 5 newtons. Force 5 newtons. In this direction is not a complete information, okay? Force 5 newtons in this direction is not a very complete information. Why is that? 5 newton in this direction isn't a very complete information. Why? When we talk about a force, the magnitude and direction don't provide us a complete idea of what is happening, right? It's not going to provide us a complete idea of what is happening. Why? See, you have a table or a pen like this. You have a pen like this. Okay? You are going to apply the same force in the same direction. Clear? Same force in the same direction you are going to apply. Okay? But based on where you apply the force, the movement will change, right? If you apply a force to the exact middle, okay, the pen will try to move in a straight line path like this. If you apply the force towards an end, it will tend to go a bit like this, right? While moving forward, it will try to move like this, clear? And at the same time, if you apply a force like this, it will tend to move like this, right? It will tend to move like this, clear? See? Same 5 newtons, same direction, same 5 newtons, same directions, but based on where you apply the force, the final result may vary, right? Clear? You know, right? If you push a table from the exact middle, it will move forward. But if you apply the same force towards the end of that table, it will try to rotate a bit, right? Clear? See, same force, same direction, still don't provide us 100% information about what is happening, right? Clear? Same force, same direction, but still not sufficient to understand the final output or the final result. See? That is the thing, okay? And there are some physical quantities that need like 100 information like this, okay? So there are different levels to physical quantities. Okay, that's why Newton physics wasn't sufficient at a certain point. Newton physics wasn't sufficient. Then we needed Einstein physics to understand some physical quantities. Just like it went on, okay, clear? So it's not like there are scalars, there are vectors. Vectors need a direction, scalars don't need a direction. No, it's not the case. There are different levels of physical quantities, okay, clear? Different physical quantities need different amount of information to be understood 100%, clear? Different kind of physical quantities need different amount of information to be understood 100%. This we should first understand, okay? So if someone gives you a statement, we need direction and magnitude to understand a vector completely. Yes, it is a correct statement. We need a direction and the magnitude to understand a vector completely. A correct statement. We can understand any vector completely by the direction and the magnitude, not a correct statement. We can understand any vector completely by the magnitude and direction, not a correct statement. Clear? Why? Force is a vector, but still magnitude and direction isn't sufficient. Clear? Force is a vector, but still the magnitude and direction isn't sufficient. Got the idea? Clear? See, so there are different levels for physical quantities. Clear? Okay. Today we are going to stop at this level where we need the magnitude and direction. Clear? We are going to stop at this level where we talk about the magnitude and direction. So today's topic is vectors. Vectors, that means physical quantities with the magnitude and direction. Okay, clear? But I again repeat, you can't understand any physical quantity just by the magnitude and direction. Okay, clear? The minimum requirement is having the magnitude and direction. Clear? Okay, so physical quantities that have a magnitude and a direction, I repeat, are vectors. Clear? But still there are more to come. Why? Some physical quantities, it looks like there's a magnitude and direction, but still not a vector. Okay? There are some physical quantities with a magnitude and direction, but still not a vector. For an example, what? Current 5 amperes, that is the magnitude, and definitely current has a direction, right? Current has a direction, still not a vector, okay? Still not a vector. So we are going to discuss about vectors a bit later again. That means I'm going to teach some theory points. and return to the definition of vector again, because still having a magnitude and direction isn't sufficient sometimes. Clear? Having a magnitude and direction isn't sufficient sometimes. Clear? All these complexities have arrived because of physics syllabus is not complete. Okay? There are 10 axioms. You can go and search 10 vector axioms. There are 10 conditions to be fulfilled if you need to make sure something is a vector. 10 conditions, 10 mathematical, extremely complex conditions. Okay? Go and search vector axioms. Okay? We don't have these 10 axioms. As a result, we have to lie a bit. Okay? Throughout the lesson. Okay? That has been the problem. Clear? Okay? So I'm not going to lie a lot. So what I'm going to do is I'm going to teach some theory points. I'm going to move forward. Then return to the definition again and make the definition a bit correct. Okay? We'll just learn the better definition or the perfect definition after learning some vector theories. Okay? Then we can, for now, it's something with a magnitude and a direction. Clear? But still, a work has a kind of direction. Current has a kind of direction, but these are not vectors. Okay? Let's talk about that later. So now let's move forward. Okay? Let's move forward. So moving forward, representing vectors, a vector is represented using a line. Vectors are represented using a line like this. where its length represent the length or the size of the vector. Okay, its length represent the size of the vector, and an arrow like this represents the direction of the vector. Clear? Arrow like this represents the direction of vector. Clear? So using something like this, we can represent a vector. This shows the length of the vector. This shows the direction of the vector. Clear? This shows the length of the vector. This shows the direction of the vector. Clear? And if this point is A, and if this point is B, if you have notations for the beginning and end of this vector, we can write this as vector AB like this. We can write this as vector AB like this. Clear? Okay. This is another notation. Clear? Or else you can give a name for this vector called A, and we can write it as vector A. To show that it is a vector, we draw a line like this. In printed notation, we usually don't use this kind of a line. What we do is we bold it. In printed notation, we bold it. Clear? We bold it. Got the idea? Clear? So these are the notations. Okay, these are the notations. Got the idea? So this is A to B. This is vector A. This is again vector A. These are different notations that we use to represent a vector. Clear? For an example, if there is 5 newtons, going from point A to point B, in this direction, we can draw this vector by you mark A, you mark B, then draw a line with this 5 Newton magnitude. Draw a line with this 5 Newton magnitude. How can you draw 5 Newtons? How can you measure 5 Newtons on your paper? Not possible. So what we do is we put a scale. We tell something like 1 Newton equals 1 centimeter. We put a scale. 1 Newton equals 1 centimeter. Clear? We put a scale. Then 5 Newtons means you have to draw a 5 centimeter line. You have to draw a 5 centimeter line. Clear? Okay. And you can call it a 5 Newton vector, but to show that it is a vector, you draw a line like this. Okay. Clear? Then talking about the magnitude of a vector, clear? There are few, the magnitude is taken by the length of this line. Notation for the magnitude of a vector is this. The magnitude of vector AB, we write like this. This is the symbol we use to show the magnitude. Clear? This is the symbol we use to show magnitude. Clear? So the magnitude of AB vector is just AB, right? This arrow represents that it is a vector going from A to B. But when we talk about the magnitude only, it's just length AB, right? Clear? So for vector A, magnitude can be written as A. Clear? Okay. Again here, magnitude of vector 5 is 5. Magnitude of vector 5 is 5. And magnitude of AB is AB. Clear? Magnitude of AB is AB. Clear? Okay. So that is the idea. Clear? So moving forward. There was a question like, do we actually have to join the fast track? No, it's not necessary. I again repeat, The reason is nowadays, you know that there's a war going on, like not that war I'm talking about. They need to postpone A-levels. But yesterday they already released A-level timetable starting 10th of August. Okay. So now, like everyone, a lot of students are protesting, okay, we need to postpone A-levels, we need to postpone A-levels. But I mean, we knew that it's going to happen, right? The main problem have been is none of the classes have finished the syllabus. Okay. So now the tuition people are in trouble. I mean, they can't finish the syllabus. They assume that the A-level would be postponed, but it didn't postpone. I mean, I think the government exactly know what has happened to the tuition industry. They know now that the tuition people are in trouble. So if there is no legal, there are some legal kind of stuff going on. Lot of legal stuff actually, lot of legal initiatives were started by tuition people. I mean, telling that it's for the sake of students, but I mean, you know, okay. So, so now everyone need to postpone A-levels, but I mean, we knew that coming. So, I mean, we saw that earlier. I mean, so everyone should have finished the syllabus fast, right? Now all of a sudden, there's no one haven't have finished syllabus yet. There's 2 months to go for the exam. Okay. And I think most of the classes will finish syllabus like 1 or 2 weeks before the A-levels, or maybe 1 or 2 weeks after A-levels. Okay. Clear? So that's what's going to happen. That has been the main problem. Okay. So need not to get a risk. Okay. So we are planning with a 6 months gap. Okay. We are planning to finish syllabus with a 6 months gap. We did that for 26 batch too. Okay. You can check that with 26 batch students. We finished with an exact 6 month gap. Okay. But I mean, why not 1 year? Okay. That is the question now. Why not 1 year? So the fast track program, we are starting just to finish the syllabus 1 year before the A-levels, okay? But it's not necessary. You can go in the normal program and finish the syllabus 6 months before the exam. 6 months is way greater than what is happening in the industry now. So still it's a win. But 1 year is better. I finished for A-levels, I finished the syllabus 1 year before. Okay, I finished the syllabus 1 year before. Why? When you finish the syllabus 1 year before, you have 1 whole year to check what are the lessons you are struggling with. You have to do that. You can do those lessons like 10 times again if you need, right? You can write full syllabus papers. You can write past papers for years, okay? So there's a lot of things we can do, right? That's why the fast track we again decided to, okay, why not 1 year? Let's try to go with a 1 year gap, okay? That's why the fast track. So it's not like things we are doing a fast track, we are teaching extremely fast. No. That's why we are doing a separate class for that, okay? It's not like we are going to teach really fast and finish things so that you won't understand things. It's not the case. That's why a separate time slot for that, okay? So the target is to finish 1 year before, okay? That is the target of the fast track, but 6 months would be more than sufficient, okay? It's compared to what is happening in the industry, a 6 months gap is perfect, okay? More than enough, okay? But still, if you think you have time and capacity, and I think you have nothing to do these days, right? You're not living a useful life these days, right? So, I mean, you can try the fast track for a while if you need. You don't have to do any additional payments. You just get the tute. So just try the fast track. If you feel like it's too much, just throw away the optics tute. Next year we'll give the optics tute again. Okay, no big issue, okay? So just since you have nothing to do these days, just try the fast track. Try both. If you think like, okay, optics is too much, I can't even handle mechanics, now I have to handle optics too, just throw away the optics book. Next year we'll again give you the optics book, then you can continue from there, okay? So just don't take it as a stress, okay? It's something additional, okay? That's why we distributed it for everyone, okay? And we send that for the online students too, clear? So let's move forward. Pay attention, everyone. So here, now this part is clear, I think. Now let's move to the negative vector. Pay attention. Let's move to the negative vector. What is a negative vector? What is a negative vector? Negative vector is a vector with the same magnitude but opposite direction. That means here if you have vector AB if you have vector AB, okay, vector AB, this is the notation for vector AB. This is the notation for vector AB. Okay. Now, the negative vector is this. Same vector, same magnitude, but only thing is opposite. Same vector, same magnitude, but only thing is it's opposite. Okay. Let's even give a name for this, A. So this is the notation of the negative vector of this guy, okay? We can even write it as negative AB. And as you see, negative A to B equals B to A, right? Negative A to B equals B to A. Negative A to B equals B to A. Clear? Okay. Then again, this one we can write as minus A. These are all the notations for vector, negative vector of vector AB. Clear? All the notations of the negative vector of vector AB. Clear? Okay. Okay, pay attention everyone. Pay attention. So moving forward, like the next main part, vector calculations, okay? So here what we are actually doing is we are learning a new domain of maths, okay? That means you just get the normal numbers. First you learn the notations. Then you learn them, how to add them, how to subtract them, how to divide them, how to multiply them. Same story, okay? Here we are just going through another line of mathematics, okay? Learning what is vectors, draw vectors, give notations for vectors. Now learn how to do calculations for vectors, okay? Even calculus, differentiation, integration, you know that you can do that for numbers, right? Differentiation, integration and all calculus. Just vector calculus, vector differentiation, vector integration. So it's just another new line of mathematics, okay? So now what we have to learn is doing calculations, okay? Doing calculations. Pay attention everyone. Pay attention. Now, the next thing is, everyone, the next thing is doing calculations with vectors. So the simplest one is adding vectors, right? So the first thing is we are going to learn vector addition. Vector addition. When it comes to vector addition, there are three theorems, okay? Pay attention. There are three theorems related with vector addition. The first one is the vector triangular law. Vector triangular law. What is that? Assume you have vector A and vector B. Assume you have vector A and vector B. So what would you do is, you will first draw vector A, right? You will first draw, how this theorem works is, you first draw one vector. You first draw one vector, okay? Then from where it stops, you start drawing the next vector. You start drawing the next vector. Now, this is the absolute beginning of this diagram, and this is the absolute end of this diagram, right? This is the absolute beginning of this diagram, and this is the absolute end of this diagram, right? Clear? So we draw a line from the absolute beginning to absolute end. this gives us the resultant, or else A vector plus B vector. Clear? This gives us the resultant. I mean, it just makes sense, right? If you walk from here to here, then here to here, what actually happens is you went from here to here, right? Clear? Clear? That's the whole meaning, right, of vector addition. If you walk from here to here, then here to here, then what actually happened was you went from here to here, right? So that is so it's quite practical, okay? So vector triangular law is not something very fancy. It's what you just see by eyes, given a name for that, okay? Clear? Given a name for that, okay? Given a name for something you already know, okay? Clear? So initial days, that's what actually Newton did, okay? People already knew a lot of stuff, but he gave some names for them, okay? I mean, the first, few main theorems of Newton, like they were mentioned as findings those days. I mean, when something falls, it falls down, not up. I mean, these things were praised a lot, by the way, okay? Okay, that is the whole meaning of fall. I mean, anything don't fall up, right? That's the whole meaning of fall, right? When something falls, it only falls down. It don't go up. So it was a finding, okay? Later given a name for that. Later, the guy identified Newton's law of gravitation and all. Okay? So like that, again, unless disturbed, stationary objects will stay stationary. Newton's first law. Unless disturbed, stationary stuff would stay stationary. What else could happen? It's stationary, yes. You're not disturbing it, so it would stay stationary, okay? So like that, the first few years was, the guy was playing around. Later, Newton is behind all the laws of motion, all the laws of gravity, many laws of optics, many laws of heat. Then to derive almost all these laws, the guy need calculus. So he invented integration, differentiation, all sort of mathematics that you are going to learn in your syllabus. Like 80% of the mathematics you are learning in your syllabus. Okay? Everything, okay? So, yes, the huge respect, but the initial days, I was playing around. Okay? So, pay attention. So, moving forward, so A plus B. So, that's something you already knew, right? Something you already knew. Again, it makes, sense. Why? You have an object here. You have an object here. You apply maybe 5 newtons in this direction, 4 newtons in this direction. In which direction would you expect it to move? In which direction would you expect it to move? Somewhere like this, right? Somewhere like this, right? Okay? So it's true. Why? You get the vector triangular law. Get one vector, draw it. Get one vector, draw it. Clear? And from where it stops, get the second vector, draw it. Clear? Now what is the absolute beginning of the diagram? This. What is the absolute end of the diagram? This. Then, see? Clear? This is the resultant we expect, right? If you apply 5 newtons and 4 newtons to the same object at the same time, you expect it to go in something like that, right? So the vector addition theorem, vector triangular law actually makes sense, right? Clear? Vector addition theorem or the vector triangular law actually makes sense. Clear? Clear? It actually makes sense. Okay? So moving forward, now back to the vector basics, definition of vector. So we tell for something to be a vector, it must fulfill vector addition theorems. Another part I'm adding to the vector addition, vector definition. For something to be a vector, it must fulfill vector addition theorems too. Why? Take this for an example. You apply 4 newtons in this direction, then 3 newtons in this direction. The resultant would be this. So what is the value of the resultant? 4, 3, what is the diagonal? It's going to be 5, right? Clear? When you apply Pythagoras theorem, if this is 4, if this is 3, this is going to be 5, right? Clear? 4 squared plus 3 squared equals 5. So according to vector addition theorem, there's a vector 4 in this direction and a vector 3 in this direction. There's a vector 4 in this direction and a vector 3 in this direction. Altogether, you would get vector 5, right? Altogether, 4 and 3, you would get vector 5. But take current for an example. You have a point like this. So 3 amperes move in this direction. 3 amperes move in this direction. 4 amperes move in this direction. 4 amperes move in this direction. What happens to the current if the next wire is in this direction? What happens? It's just going to be 4 amperes plus 3 amperes, just 7 amperes, and go through this wire. Clear? If 4 amperes electrons cannot be destroyed or developed here, okay? So as a result, if you receive 4 amperes and 3 amperes at this point, together 4 plus 3, 7 amperes will continue, okay? 4 plus 3, 7 amperes will continue, okay? So it doesn't care about vector addition theorems, okay? Clear? Current looks like a vector, has a magnitude, has a direction, but doesn't care about vector addition theorem, see? Clear? Doesn't care about vector addition theorem, so not a vector. See? Like that. Now a better definition would be, pay attention, a better definition would be a vector is a physical quantity with a direction and a magnitude and follows vector addition theorems, okay? Learn whatever you learn perfectly, okay? Clear? We can't have a slight idea about physics and get a good result in A levels, okay? Clear? So learn whatever you learn to the point perfectly. So vector is a physical quantity with a magnitude and a direction and follows vector addition theorems. Clear? That would be the perfect definition. The best definition for now. And there's no issue if you interchange them, okay? You can interchange them. In vector addition theorem, without any issue, you can interchange them. So instead of drawing the 4 first, then 3 second, you can start with 3. If you like, you can start with 3, then go for 4. Still you get the same resultant, okay? So you don't need to follow an order, okay? Clear? Next. Okay, many questions like about parallel moving and everything. So I'll talk about them, okay? I'll talk about them now. Yeah, if you like, I mean, if you're okay with Sinhala medium, Sinhala medium optics lesson happens today night. We are starting the Sinhala medium optics lesson today night at 8 p.m. 8 p.m. we are starting optics lesson for Sinhala medium students today, okay? If you are okay with the language, if you like, you can join the Sinhala medium one too. But we are starting a separate one for English medium students, okay? So pay attention now. Pay attention. The next one. Moving forward, okay? Moving forward, the next theorem, next vector addition theorem is vector polygon. That means what if you have more than two vectors? Pay attention. A, B, and C. What if you have more than two vectors? So just draw a polygon, that's all. You get the first vector. Don't think about the order. Just get the first vector, vector A. Get the first vector, vector A. Draw that. And it has to stop somewhere. Then get the next vector. From where it ends, draw the second one. From where it ends, draw the second one. Then it again stops somewhere. It again stops somewhere. Then get the next one. Clear? Then get the next one. Again, draw it. Again, draw it. Okay? So this is the absolute beginning. Now what is the absolute beginning of your diagram? This. What is the absolute end of your diagram? This. Okay? So what would you get? This is going to be the resultant, okay? This is going to be the resultant. Absolute beginning of your diagram and the absolute end of your diagram, okay? Clear? So this is going to be the resultant. Again, makes sense, right? You walk in this direction, then in this direction, and then in this direction. You actually went from here to here, right? Clear? So this makes sense. But I mean, if they ask you to draw, prove vector polygon theorem. Pay attention, stop talking. So we start at a certain point, draw three vectors in order. Then the resultant will be given by the remaining line, okay? Remaining line that you need to complete the polygon, okay? Resultant can be taken by the remaining line that we draw to complete the polygon, okay? Now, if someone asks you to prove this vector polygon theorem, you can do that. How? Draw two triangles. That means, assume you know nothing called vector polygon theorem. You only know the vector triangle of vectors, okay? So you get the first vector, pay attention. You get the first vector. You get the first vector. You get the second guy. You get the second one. You complete the triangle. This is the beginning of the triangle. This is the end of the triangle. So, this is going to be the completed triangle. So, this is going to be the resultant. This is going to be the resultant. Okay? Now you only have one vector here. This guy. Then you get the third vector. Again, do vector triangular theorem with this guy and this guy. Again, do vector triangular theorem with this guy and this one. Okay? You can do vector triangular theorem with this one and this one, right? Here, because you had two vectors, you simplified it to one vector. Now you only have one vector, this. Now you have this and this. So you take this one and this one, draw a triangle for them. So first this one, then from where it ends, you draw this one. Again, vector triangular theorem. Clear? Now this is the triangle. Now this is the triangle. Clear? This is the triangle, okay? This is the beginning of that triangle. This is the beginning of that triangle. This is the end of that triangle. This is the end of that triangle. Clear? Then you draw the resultant for this triangle. You draw the resultant for this triangle like this. Okay? You first get these two, draw the triangle, get the resultant, then draw this and this as a triangle, get the resultant, again using a triangle. But after everything, now you see the blue color line wasn't necessary, right? After everything, you see the blue color line wasn't necessary, right? Here, it's just an intermediate line. Just an intermediate line. The blue color line isn't necessary. So this is the resultant. Clear? Clear? So vector polygon. Okay? Vector polygon. Clear? So it works for like 100 vectors till it works. Okay? Not for 3 vectors. If you have 100 vectors, just draw all 100 vectors in order. Okay? Just draw all 100 vectors in order. Still you are going to get the answer. Okay? Clear? Draw all 100 vectors in order. Still you are going to get the answer. Clear? Everyone? Okay. So that's all. Just draw 2 lines to represent the resultant always. Okay? These are not rules but conventions. Okay? So just draw 2 lines to show the resultant. Is it clear, everyone, up to this point? Clear? Okay. So we learned vector triangular theorem and the vector polygon theorem, right? Okay, let's move to some questions. Go to your tute. So you don't have to write anything actually, okay? You don't have to write anything actually. Everything is shown here. Pay attention. We are not going to write notes for mechanics. Why? Mechanics is nothing about notes. It's all about doing questions. Thousands of questions, okay? It's all about doing a lot of questions, okay? So we are going to save all the time to do questions, okay? That's the only way that we can be good at mechanics, okay? Just by doing a lot of questions, okay? So, go to exercise. Short questions part. In exercise, short questions part. Quickly go through the questions. No. In a notation like AB, I'm just answering the questions. This arrow represents not the direction, the starting point and the final point, okay? It's just telling that this vector goes from A to B. So if you know where location of A and B, then you know the direction, okay? It's not like if this vector is going up, you write it like this. No, okay? Clear? This is the notation, that's all. Clear? This doesn't show the direction. It just tells that it's going from A to B, that's all. Quickly go through the questions. You still didn't receive the results yet, right? What's the point of... How to subtract a vector? A good question. How? How? Just still use the vector addition, okay? Still use the vector addition. Just do there's no vector subtraction theorems, okay? There are no vector subtraction theorems. So what you do is, you do the same addition, but for the negative vector. That means if this is A, if this is B, this is A plus B. This is A plus B. Okay? What if you need A minus B? What if you need A minus B? You get A plus minus B. But if you need A minus B, you just write A plus minus B. A plus minus B. Clear? Then you get vector A. What is vector minus B? The same vector in opposite direction, right? Same vector in opposite direction, like this. This is minus B. Same vector in opposite direction, minus B. Clear? You get vector A, you get vector minus B, you add them. Okay? You get vector A, you get vector minus B, then add them. Okay? Clear? A minus B. So this is the addition of A and minus B. Got the idea? This is the vector triangle for the addition of A and minus B. Okay? This is the vector triangle for the addition of A and minus B. Clear? Okay? Addition of A and minus B. So you can get the truth from the drive link. Okay? Mali, check the live a bit. Check the live a bit. Okay. You can get the tunes from the drive folder, but within today's class, I'll provide you information on how to get tunes, okay? How to get tunes if you didn't receive them. We actually send close to 1,000 tunes, so like most of the students should have the tune by now, okay? Most of the students should have the tune by now. And to join the group or anything else, if you need the past recordings or anything, just contact this number, not 70-154-6825. Contact this number for anything else. To get information, to any other support, to join the group or anything else, okay? To join the group or anything else, okay? Not 70-154-6825. Let's move forward one by one. Okay. Then after this, go to question 20. After 12, go to question 20. Okay. First one. This is vector A. This is vector B. So just draw a vector triangle, okay? Still, line is also a triangle with zero area, okay? Pay attention. What is A plus B? You first, again vector triangular theorem, okay? You draw vector A. This is where it stops. Start from there and draw vector B. Draw vector B. This is the absolute beginning of the diagram. This is the absolute end of the diagram. Pay attention. This is the absolute beginning of the diagram. This is the absolute end of the diagram. So what you do is you get the resultant, okay? This is going to be the resultant, the line you draw from the beginning to end. Clear? Line you draw from the beginning to end, okay? So it needs not to look like a triangle, okay? The theorem is you get one vector, then draw the second vector, then you have the beginning of the diagram, end of the diagram. You draw a line from the beginning to end. You draw a line from beginning to end, which gives you the resultant, right? Okay, which gives you the resultant. So this blue color one is A plus B. This blue color one is A plus B. Okay, clear everyone? Okay, next one. No, you don't have to use a scale for anything, okay? So here the vectors are in the same direction. There was a question online, so I think you got the answer, okay? Still it's a triangle. Still it's a triangle. Next. Question 2. Question 2. Pay attention. First vector A. First vector A. Then you have vector B. Okay. Pay attention now. Again draw a triangle, okay? How? You get one vector. Now you need to draw A plus B. So you draw a triangle. How? You get vector A. You get vector A. Okay. You get vector A. This is vector A. Then it stops here. Then it stops here. You start the second vector there and draw vector B. Start the second vector there and draw vector B. Pay attention. This is vector A. It stops here. Then start vector B from there and draw. Now what is the absolute beginning of your diagram? This is the absolute beginning of your diagram. What is the absolute end? This. So resultant is the line you draw from beginning to end, right? Resultant is the line you draw from beginning to end. So this is the resultant. A small line like this. This is A plus B. Clear? And practically it makes sense. You walk 5 meters, walk 3 meters back, your actual displacement is 2, right? That's the whole meaning of resultant, right? You walk 5 meters, 3 meters back, your actual displacement is going to be 2 meters, right? That's the whole meaning of a vector, okay? That's the whole meaning of displacement, right? No, optics duty is not there. You will get another link for the optics one and all. Or else we'll add that. Okay? We'll add that to the same drive link. Just keep it on. Question 4. This is A. This is B. This is C. A, B, and C. Pay attention, everyone. Pay attention. Stop talking now. I mean the first one, A plus B. You draw A, then draw B, then this is the resultant, right? This is the resultant. Then A minus C. This is A. This is A. What is minus C? Same vector but opposite. Pay attention. Same vector but opposite. Pay attention. Pay attention. Stop talking, everyone. What is minus C? Same vector but opposite, right? Same vector but opposite. So now, what is A minus C? Equals A plus minus C. A minus C equals A plus minus C. Which means you draw A first. You draw A first. Then draw minus 7. Then draw minus C. So this is the resultant, okay? You draw A first, then minus C. This is A plus minus C, which means A minus C. Clear? Let's try the fifth one. A, B. What is minus C? This is minus C. Pay attention. This is minus C. So what is, pay attention, what is A plus B minus C means? A plus B minus C means, pay attention now everyone. A plus B minus C means A plus B plus minus C. So just draw a polygon, right? Start from A. Start from A. Start from A. Go to B. Go to B. Start from A. Go to B. Then minus C. Then minus C. This is the beginning of your diagram. This is the end of your diagram. You just complete the diagram. You draw a line from beginning to end. This gives you the resultant. This gives you the resultant. Clear? Okay? Pay attention. You just draw them in order. You just draw them in order from beginning to end. Then complete the diagram, okay? Then complete the diagram. I mean, I think that question was there. I mean, just tell me this. That question was there somewhere, I can't remember the number, so I'll just give you that question. Tell me there's vector A, another vector A. That means same magnitude. Same magnitude. But the angle between their direction is theta. Angle between their direction is theta. They are resultant. They are resultant. Pay attention. Their resultant is still A, okay? Their resultant is still A. Got the idea? That means magnitudes are same, okay? Not the directions. Magnitudes are same. You have vector A and vector A. Different directions but same magnitude, okay? Different directions and same magnitude. And the magnitude of the resultant is also same. Okay? Magnitude of the resultant is also same. What is the angle between the directions of these vectors? Quickly find. Quickly find the angle between the directions of these two vectors. Quickly get the answer. What is theta? What is theta? Find theta, whether it is 30, 45, 60, 90, 180, what? Quickly. Sorry? Oh, like the angle between them is theta, and it's not 60, okay? I just heard 60 everywhere, that's why I said. Ah yeah, 60 is here in the answers too. 60 is very close to the correct answer, but not exactly. I got the correct answer from one person. Same? Yeah. Yeah. Yeah, now the answer is there. So you guys like to receive results or not? I mean, then how the hell are you going to go to the university? I mean, you have marks releasing every month. Different marks, and you're not receiving any good looking marks in university. I said to you that, right? In our department, there are some exams like out of 100, sometimes close to 80 students fail out of 100, and I'm from electronics department, so that is the most difficult department to get selected in University of Moratuwa. That means the best people in University of Moratuwa go to electronics department. So these are not the normal kind of people you see. They have been the class first from grade 1. Okay. Now see 80, close to 80 of them fail sometimes in exams. So these are not very good looking exams. Okay. But nobody cares actually. I mean, Failing exam becomes something very normal in the university. So no big deal, but I mean. Yeah, the answer is 120. Answer is 120. How? Let's draw a triangle. Now pay attention everyone, stop talking. Pay attention. I need everyone to be silent, pay attention. You have the first vector. I mean, you are drawing a triangle, all three legs should be same, right? All three sides should be same, right? So the only way you are going to draw that is, after this, you have to draw the second vector like this. Then the resultant should be like this, right? That's the only way possible, right? Clear? That's the only way possible. You need a triangle, a vector triangle, all sides equal, right? That's the magnitude of vector 1, magnitude of vector 2, and the resultant has the same size. Okay? So you draw vector A like this. From where it stops, you draw the second vector. Then you draw a line from beginning to end. You draw a line from beginning to end. Clear? And that is also A. So this is A, this is A, and this is A. This is A, this is A, and this is A. That means this is 60, this is 60, and this is 60. Then what is the angle between the directions of vectors? 120, right? Why? What is the direction of this vector? The direction of this vector is this. The direction of this vector is this. Clear? This is the direction of this vector. What is the direction of this vector? It is this. Direction of this vector is this. Clear? Then the angle between the directions of these two vectors is this, which is 180 minus 60, right? 180 minus 60, which is going to be 120 degrees. 120 degrees, clear? Okay. Okay. So let's move forward with the other questions. Question 12 and question 20. Question 12 and question 20. Others, if possible, finish all the questions, okay? Just keep doing all the questions if possible. If you have time, don't waste time. Just keep doing all the questions. Do you find the fountain of youth? You look like 12. I mean, it's true. Yeah, you actually maybe look like, maybe, I mean, definitely like younger than you guys, okay? I mean, I look younger than you guys for sure. Okay. Question 12. Two vectors of magnitude 5 Newton and 12 Newtons act at 90 degrees. You have, a plane travels 120 kilometers east. This is east, right? For this, that right? So 120 kilometers in east. Then 50 kilometers in north. 50 kilometers in north. Find the total displacement. So you know, right? What to do? Pay attention, everyone. How? You first draw this 120 in east. Then after that, draw this 50. Draw this 50. Now what is your resultant? This, right? And is it 130? Yes, right? 120 squared plus 50 squared, I think equals 130 squared, right? Yes, right? So the resultant is 130 kilometers. Now pay attention, everyone. How would you write the perfect answer? This is 130 kilometers and it is a vector. So it's better to show the direction properly with angles, okay? When presenting the answer. When presenting the answer, it's good to show everything with the angle and all. So when you are writing the final answer, is it clear up to this point? 120, 50, so you get 130. But still, a vector, to be complete, you have to give the perfect magnitude and the direction both, right? So let's find theta. How? There's plenty of ways you can find theta. Then use the logbook, okay? For an example, you can find tan theta. You can find tan theta. It is 50 over 120, right? 50 over 120. 5 over 12. So tan theta, pay attention. Tan theta is 5 over 12. So you either, for now, you know this notation, right? If tan theta is 5 over 12, theta is tan inverse 5 over 12, right? If tan theta is 5 over 12, theta can be written as tan inverse 5 over 12. That is a notation to write for theta, okay? So for now, let's keep it like that. But the actual thing is you have to use the logbook. If you know tan theta, using the logbook, you can find theta, right? You know how to find theta when given tan theta, right? Using the logbook? Yes, right? Okay. Pay attention. Now you write the final answer like this. You just draw it and show that this is east. Pay attention, everyone. Pay attention. I know the question is easy, but you can't skip any step. Because I mean, everything should be perfect, even the final answer. So this is east. This is east. The angle is theta from east. Okay? Angle is theta from east. Clear? So you show the angle theta from east. Clear? Then you write the magnitude, 130 kilometers. You write the magnitude, 130 kilometers. Then here you define theta, tan inverse. It's better if you can find the value from the logbook, or else tan inverse 5/12. So this is your perfect final answer, okay? Magnitude, unit, direction properly defined. Otherwise, you're not going to get marks, okay? Because at the end of the day, it should be correct by definition. You may use, even in a very complex question, some students are really good at that. They use all the complex mathematics they know, somehow draw a diagram and get the answer, but the final answer is not presented well. They have just written a value and a arrow, that's all. No proper direction defined. So we have to show that this is east, and relative to east, I give theta. Clear? So you have to write that properly. You have to write the magnitude, you have to write the unit. Then only it becomes a complete answer, okay? Clear? Question 20. Question 20. Question 20. So tube delivery information will be available in the YouTube live in the Zoom. So if you haven't received tube set, you have to put a message to that number, okay? You haven't received the tube set, you have to put a message in for that number, requesting for tubes, mentioning your medium and what are the tubes you need, your address and number, everything, okay? Then we'll send the tubes within 5 days maximum, okay? The numbers will be available in the YouTube live and the Zoom chat. Okay, question 20. Anyone need me to explain this again? No, right? Anyone? Okay, invigilators, just inform me quickly, okay? If there's any issues, if there's any common issues. Online students? Okay. So pay attention. This angle, there was a question. In the previous questions, pay attention everyone now. Yes, in the previous question, I didn't find this theta because there wasn't sufficient information anyways, right? There were just lines, no angles given properly, okay? So there wasn't sufficient information to find this theta. That's why I didn't go there. But in actual question, all the directions will be available. Magnitudes and the directions will be available. So definitely for the final answer, there's a perfect direction, okay? Definitely for the final answer, there's a perfect direction. Clear? Okay. So definitely you can find theta. Okay. Definitely you can find theta. Okay. You can find tan theta. Okay. Clear? Or sin theta or cos theta, anything. And using that you can find theta, right? Clear? So you have to present everything in the final answer. What is your resultant magnitude and unit? What is the angle as tan inverse? Okay. Ideally not tan inverse, you have to find it using the logbook. No, writing the final answer like this would be sufficient. No need to go through statements. Okay. Ideally this would be sufficient. Okay, this shows all the information required, right? Yes, this shows all the information required. Okay, question 20. Question 20. Now pay attention, everyone. Pay attention, stop talking, last rows. Pay attention now. Last rows, pay attention. Question 20. The minimum resultant of two forces is 16 newtons. 16 newtons. The maximum resultant is 40 newtons. When they act at 90 degrees, find the resultant. You know when we get the minimum and maximum, right? When do we get the minimum and maximum? The maximum we get when both 40 newtons, let's take the two forces as F1 and F2. Let's take two forces as F1 and F2. Clear? Okay, there's a common question here. Tan inverse is just a notation, okay? It's just a notation. That means if sin theta is 0.8, cos theta or cos alpha is 0.7. If tan beta is 0.4, you can write theta as sin inverse 0.8. You can write alpha as cos inverse 0.7. You can write beta as tan inverse 0.4. So this is just a notation. You know log and log inverse, right? Something like that. Clear? Like log and log inverse, this is something like that. Now, pay attention. Why do we learn this? I mean, sometimes in A-level exams, you won't find enough time to find all the angles, go through the logbook. Maybe you start doing a question at the last 10 minutes. So you don't have enough time. So in these kind of scenarios, you can just leave the answer like this. Still it would be very correct to the very close to the final answer, okay? This is theta as a notation, sin inverse 0.8. When you see that, when you write that, anyone knows sin theta is 0.8. Okay? Clear? So this is a notation. Okay? This is a notation we use. Clear? Okay, so we can use this. Whenever we don't have enough time to use the logbook, can find the final theta. Okay? Clear? Whenever we don't have enough time to find the value used in the logbook. Got the idea now? Okay, it's good that, I mean, quickly inform invigilators when you have any issue, and invigilators quickly inform me if there's a common issue. Okay? Clear? Quickly inform me when there's a common issue. So what you need to do is, if there's an issue, just quickly inform. Then if few people ask that, we know that there's a problem, so they will inform me. So I can quickly do that again, okay? For the online people, I directly see the both live chat and the Zoom chat, so you can just put it there. Okay. Again, like, there are like in the YouTube live and Zoom and everywhere and from other websites, there are like close to 1,000 students joining. So if only one student asks something, sorry, but I can't answer. Okay, I mean, you understand that, right? I always try to answer all the questions, but assume we go through a concept. There are close to 1,000 students and one student asks a question and only one. Everyone else tells that they understood. I mean, sometimes I may have to leave that and do that later, okay? Sometimes I may have to do that, but what should happen is all the students, when there's a problem, put that on the chat. Mention that to the invigilators. Then I know that it is a common issue. Then I know at least like 2-3 students ask the same thing, okay? At least when 2-3 students ask the same thing, I know that there's an issue like, as such, okay? Clear? So then I can quickly go through that, okay? And if there's any student who are unable to use the live chat and the Zoom chat, that means the students who are joining from other websites, they can use this number, okay? They can use this number to ask any question, okay? Students who are unable to use the live chat and the Zoom chat who are joining from other websites, you can use this, okay? To send any question, okay? I just check everything, okay? I check that number, check the live chat and the Zoom chat. Okay, let's move forward. Let's move forward. Pay attention, everyone. Pay attention. So solving the inverse, just like log inverse, use the logbook. If sine theta is 0.8, you know how to get theta, right? Pay attention. If sine theta is 0.8, you know how to get theta, right? Clear? So using that, you can go for theta, you can go for alpha, you can go for beta using the logbook, right? I can't even remember, like, to find cos theta, you have to go from the bottom of the logbook, right? There are these kind of issues. Any students who don't know this kind of stuff, raise your hand. Ideally, I think there are students from Excel to A level. They may not know the logbook, right? You had calculators. Now you are in trouble. All of a sudden you choose to do local A level, so now your life is ruined. No calculators anymore. Anyone? Anyone? Okay, see, we have few. So I'll do something about that, okay? I'll do something about that. Yeah, let's do something about that. I'll clarify that issue within a week, okay? Okay, pay attention. Question 20. And hope you went through the last Thursday morning session, measuring instrument session. Okay? Yes, right? Everyone? Students who didn't join the Thursday session or didn't watch that? Do we have? Really? Watch that, okay? Because we do all the practicals at the studio. And as you saw, there's a very good setup in the studio, okay? Clear, there are like 9 cameras. It's a pretty expensive setup, okay? So we can show any practical with every detail at the studio. That's why we do practicals at the studio, okay? So everyone definitely watch that, okay? There's the recording available in our YouTube live, in our YouTube channel, okay? Okay, pay attention, everyone. So now, pay attention, stop talking, everyone. Pay attention now. Okay, now, you have F1 and F2. This is how you get the maximum, right? When the both forces are in the same direction. This is how you get the maximum resultant. Clear? How do you get the minimum resultant? F1, F2, when they are in opposite direction, right? How do you get the maximum of two forces when they are in the same direction, right? That means here the resultant is F1 plus F2. Here the resultant is F1 plus F2, okay? What is F1 plus F2? That is the maximum. That should be 40. That should be 40, okay? F1 plus F2, that is the maximum. That should be 40, right? Then what is the minimum? F1 minus F2, right? What is the minimum? It is F1 minus F2, right? When they are entirely opposite, right? When they are entirely opposite to each other, which gives us the minimum, that is 16. So you have 1, you have 2, solve them to get F1 and F2, okay? Solve them to get F1 and F2. How? You add 1 and 2. 1 plus 2. 1 plus 2, which gives you F1 plus F2 plus F1 minus F2. Minus F2 and plus F2 cancels out. So you have 2F1 equals 40 plus 16, which means 56. Clear? F1 plus F1, 2F1, my plus F2 minus F2 cancels out. 40 plus 16, we have 56. So what is F1? What do we get by dividing this by 2? 28, right? 28, right? Yes or no? Just to confirm. Okay. Next. If F1 is 28, you have 28 plus F2. Here 28 plus F2 equals 40. So F2 equals 12. F2 equals 12 Newton and F1 equals 28 Newtons. Clear? F1 equals 28 Newtons, F2 equals 12 Newtons. Clear? Okay. F1 28, F2 12. Okay. So now they are acting in 90-degree angle, right? That's what they mentioned, right? They are acting in 90, right? So just draw them as a 90-degree system, which means 28 like this, then 12 like this. Then this is the resultant. Then you can use maths. R squared equals 28 squared plus 12 squared. R equals square root 28 squared plus 12 squared. Do we have a nice answer for this? No? Yes or no? No? Then let's keep it like that. I mean, you have to actually go for the final answer. I mean, I'm anyways not going to use the logbook here, so I mean, I actually can't remember how to use the logbook now. Plus 12 squared. It's 30.46. 30.463 if you need more decimal points. Okay. Got the idea? So the summation of two vectors is 40. Subtraction of two vectors is 16. Why? They are telling that the maximum possible, minimum possible. That means exact summation and exact subtraction, right? That is the maximum and minimum possible, right? Okay. Then you have these two, you have two simultaneous equations for F1 and F2. You solve these two simultaneous equations, get F1, get F2, then get the final answer, clear? Then get the final answer, clear? Then you know that they are acting in 90 degrees. So you put them and draw a 90-degree triangle. draw a 90-degree triangle. Then using the vector triangular law, you get the resultant. You get the resultant. Clear? Got the idea, everyone? Clear? Okay. Here, no need to mention angle, okay? Why? They are just telling 90 degrees, not a very specific direction. Whether it's east or north, nothing, right? So you just have to write the magnitude of the answer, right? No very good reference to the direction, right? They are just telling 28 and 12 are 90, that's all. Not any specific direction to north or east, so no clue about a proper direction here, okay? So I'm not going to get the angle here. Okay. So the final answers unit should be newtons, okay? Final answers unit should be newtons. Pay attention, everyone. Quickly finish writing. Okay. Here, like this shows another problem with, even when it comes to higher levels of vectors, pay attention, when it comes to higher levels of vectors, see, sometimes even vector addition laws don't give us the perfect, sometimes even the vector addition law don't give us the perfect result. That means even using the vector addition law, we won't exactly know what happens. Why? For an example, take you have 5 newtons in that direction and 5 newtons in this direction acting on an object. According to vector triangular law, what is the resultant? 0, right? Why? You draw 5 newtons in this direction, pay attention. You draw 5 newtons in this direction, then go back 5, right? Then you return to the same point. That means there's no resultant, right? You return to the same point, so there's no actual resultant, right? So the vector addition theorem gives you 0. Clear? But you won't actually know what happens to the object, right? Why? If these two 5 newtons act like this, the object will not move. Yes, the object will not move if these two forces act like this. Yeah. But if these two forces act like this, it's going to rotate. But the vector triangle will never tell that, right? See? If these two forces act like this, the pen will rotate, right? See? It will rotate. But the vector triangle will never tell that, right? Vector triangle will never tell that. So that's the problem with higher levels of vectors, okay? Clear? Here, there are higher levels of vectors. So vector theorems, vector additions, vector definitions don't fulfill them 100%. Don't give us an absolute clarity about what is happening. Clear? The vector triangle will never tell that the system is rotating. It will just tell 0. So I may think, okay, there's nothing happening. But the object is actually rotating, okay? See? That's a problem with higher levels of vectors, okay? Do we need the interval today? Shall I do a few more theory points and give the interval? Maybe like... Wait, we'll see. Okay. So get the interval and try these questions. Get the interval and try these questions. But I mean, soon after the interval, I'm not going to go through these questions. I'm going to jump to vector parallelogram theorem, okay? So be here on time. So maybe be here by 5:25 maybe within 15 minutes. Try to be here on time and do these questions. And just for the students who need a prayer room, you can use the all the studio and the hall next to that, okay? Okay, it's available there. Just go and talk with the invigilators. Check. Let's quickly go through the questions you have asked. Yes, 28 and 12 can be shifted, no issue. Malin. 28 and 12 can be shifted. Here, no big issue. Same answer you are gonna get anyways. Okay, I'll check that heat question. Vectors and matrices. We'll see whether we can do that. It's very difficult to do that in the physics domain because, I mean, it's not in the syllabus. We'll see. Okay. Let's go through questions one by one until everyone return to the class. Do these questions. Do these questions. Well, we need that tube 3 mechanics for today's 6:30, 7:30 session. Well, and put that tube and the optics tube both to the drive link, same drive link they have, same drive link. So one thing to pay attention, I'm just referring to some questions you asked, okay? I'm just referring to some questions you asked. I mean, A plus B is not equal to A plus B, okay? Clear? Vector A plus vector B will never be equal to A plus B unless they are in the same direction, okay? Clear? Why? This is a vector addition, okay? This is a vector addition, which means vectors are involved, okay? Directions are involved. Directions are involved. So if this is 5, if this is 3, it's not going to be 8. If this is 5 and if this is 3, it's not going to be 8, okay? It's some kind of a random value. It's some kind of a random value you get by solving this, okay? It's going to be some kind of a random value you get by solving this, clear? But I mean, A plus B means what? Just A means magnitude of A, okay? Just A means magnitude of A. That means just the number 5. Just B means magnitude of 3, magnitude of vector 3, which means 3. So it's going to be 8, okay? So try to have a good clarity about notations, okay? Always try to have a good clarity about notations. Okay, next. Any other questions? This was one of the questions you asked. Next. I'm just going through the question numbers. These are not actually difficult, okay? Question 16. Question 16. There's a velocity 3 in east, velocity 4 in north. Pay attention. Velocity 3 in east, velocity 4 in north. Find its speed and direction. So you have the value 3 and 4, you get 5. You get 5, the value is 5. Value is 5. Then what about the direction? Use theta for that, okay? Use theta for that. So 3 and 4, the final value is 5 by applying Pythagoras theorem. So you can get tan theta here. Again, you can find tan theta using 4 over 3. You can get tan theta using 4 and 3, right? Then you get theta equals tan inverse 4 over 3, right? Theta equals tan inverse 4 over 3. So your final answer would be, this is east, angle theta, and theta is this, then the value is 5 with the unit meters per second. With the unit meters per second. This would be the complete answer, okay? Clear? Next. Question 23. Question 23. Particle is acted by two forces. 12 newtons, 16 newtons at an angle of 60. Pay attention. At an angle of 60. What is the magnitude of the resultant force? Now pay attention. Pay attention. What is the magnitude of the resultant force? So you first draw these 12 newtons. This is where this 12 newtons stops. And this is its direction. This is its direction. Then you draw the second vector, okay? Then you draw the second vector. It is 16 newtons, okay? Second vector is 16 newtons. It is going with an angle of 60. It is going with an angle of 60, okay? It is 12 newtons in this direction. Compared to that direction, 16 newtons is has a 60-degree angle, right? See, that's how we properly draw them, okay? 12, 16, and between them you have an angle of 60, okay? So 12 here, the second one in this direction, because this angle is 60 compared to this direction, okay? This angle is 60 compared to this direction, okay? Then you get the resultant. This is 16. This is 16. Then you get the resultant. This is the resultant, okay? This is the resultant. Clear? Now in this kind of a scenario, do you know sine law, cosine law kind of stuff? Yes or no? From maths or from previous stuff? Excel, right? So at Excel people should know, right? At Excel or Cambridge A-level people, O-level people should know. In local O-levels, did we have sine law, cosine law kind of stuff? No, right? Okay. So here, now we are facing a trouble, right? It's not 90 degrees. It's not 90 degrees. Clear? Since it is not 90 degrees, we don't have a proper way to find R, right? We have to use some amount of maths for that, okay? Clear? We have to use a certain amount of maths to find R, clear? Okay? We have to find a certain amount of maths to find R, clear? Why? You have 12 and this angle is 60, then you have 16, then you have 16, but you don't have a direct method to find R, right? So we can use a certain amount of maths here. That is, here you have 12, here you have 16, like this. Okay. Then the resultant would be this. The resultant would be this. Okay. Resultant would be this. Okay. And the angle between 12 and 16 is this. Angle between 12 and 16 is this, which is 60 degrees. Pay attention. Which is 60 degrees. Angle between 12 and 16 is 60 degrees. Clear? Okay. Then we can use a part like this to go for the final answer. Now the problem is, why can't we use the maths we know? Because we don't know, we don't have a proper 90-degree triangle or anything like that, right? We are not capable of finding R using this 12 and this 16 because we don't have a proper 90-degree triangle or something like that to apply Pythagoras theorem or something like that, right? So the solution would be just draw a triangle like that. Just draw a triangle like that. Clear? Draw a triangle like that. Then I can try. This length is 16, right? This length is 16. Okay? So let's take this distance as x and this distance as y. Okay? Then what I can do is, again this is a 90-degree triangle, right? Again this is a 90-degree triangle. Okay? Then we can write cos 60 equals what? Cos 60 equals x over 16, right? X over 16, right? Cos 60 equals x over 16, clear? X over 16, this over this. Then sin 60 equals what? Sin 60 equals y over 16. Y over 16. Is that clear? Sin 60 is y over 16. Okay. Then I can write x equals 16 cos 60. 16 cos 60. Y equals 16 sin 60. 16 sin 60. Okay. 16 cos 60 and 16 sin 60. Okay. Now what? Now we have a method, right? Why? Now I know this whole length. Now we have this whole length. Clear? And these have, again, these two values we know, right? Okay. So then I can apply the Pythagoras theorem and find R. Okay. I'm going somewhere with this question. Okay. That means we are going to create an equation. Okay. So first, listen to this. Later we can write. So when I try to solve that, I'm going to see more information like this. What is this actual distance? It is 12 plus x, right? This actual distance is 12 plus x. Okay. What is this distance? Y. Clear? So now I can write r squared equals r squared equals this squared equals 12 plus 6. 12 plus 6, okay? 12 plus x squared plus y squared, okay? 12 plus x squared plus y squared, okay? It is 12 plus x squared, this squared plus this squared equals this squared, right? Here, using this whole triangle, okay? So I'm gonna write r squared equals 12 plus, what is x? This is x, 16 cos 60. 16 cos 60 squared plus y squared. What is y? Y is 16 sin 60, right? Y is 16 sin 60 squared. Okay. So when I expand this, what would I get? This is a plus b squared, right? Which would be a squared plus 2ab plus b squared, right? A, and this whole part I take as b. Clear? Then I can write r squared equals a squared, which means 12 squared plus 2ab, which means 2, a means 12, b means this whole part, 16 cos 60, 16 cos 60, here 2ab plus b squared. What is b squared? This squared, 16 cos 60 squared, and you have another 16 sin 60 squared too, right? This guy is here, okay? This squared plus 2ab plus this squared plus this one, okay? So here I can write this as r squared equals 12 squared plus 2 into 12, 16 cos 60 plus, so what is this squared? AB squared, A, B, A, B. So in this case, AB squared would be A squared, B squared, right? AB squared would be A squared, B squared, right? So I can write Here also I'm going to get 16 squared cos 60 squared, and cos 60 squared we write as cos squared 60. This is just a notation, okay? You know that, right? That means this is just a notation. That means cos 60 squared, cos 60 squared can be written as cos squared 60, okay? Cos 60 squared can be written as cos squared 60. Okay, it's just a notation, you have to know. Just a notation. So I can write 16 squared here, 16 squared cos 60 squared plus here 16 squared sin squared 60 sin squared 60. Okay. Now this part is 16 squared, right? That you know, right? This part can be written as 16 squared common. So I take that out. 16 squared common. So I take that out. I have cos squared 60 plus sin squared 60, right? Clear? I have 16 squared, I take that out. I'm going to explain this again with symbols and all, so don't worry. 16 squared I'll take out. I have cos squared 60 plus sin squared 60. What is cos squared 60 plus sin squared 60? We derived that in the class, right? Didn't we? Did you do that here or you learned that somewhere else? Here? No, from your math class. Or in O levels. So not from O levels, as I think, from your math class, right? So bio people, do you know that? Bio people, do you know that cos squared 60 plus sin squared 60 is 1? You know that or not? I mean, would take just, second to prove. Pay attention, for any angle, x, y, a, theta. What is sin theta? Pay attention. What is sin theta? Sin theta is y over a, right? Sin theta is y over a. What is cos theta? Cos theta is x over a. Cos theta is x over a. Sin theta is y over a. And cos theta is x over a. Then sin squared theta plus cos squared theta means square root of this sin theta, okay? Square root of this sin theta. That means y over a squared. Clear? Sin squared theta means sin theta squared. It's just a notation, okay? Sin squared theta means sin theta squared. Sin theta squared means y over a squared. Cos theta squared means x over a squared. Then you get y squared over a squared plus x squared over a squared. This is common. This is common. A squared is common. So you write it here. Here you get y squared plus x squared. What is y squared plus x squared? What is y squared plus x squared? What is y squared plus x squared? Again a squared, right? Y squared plus x squared. It is again a squared, right? Clear? So a squared over a squared, you get 1. So maths people, when you see something like this, you should now understand. No, like proof required or sin theta squared, cos theta squared, it should just occur to you, okay? Okay, maths people, you should I mean, with time, you have to grow that ability, okay? With time, you have to grow that ability. You see something mathematical, you have a nice understanding about that. All of that. Okay? So you haven't seen sine squared plus cos squared theta, anything like that. Now all of a sudden you see, okay, sine squared plus cos squared theta, oh, it's 1. Like that, I mean, you should grow that kind of ability with time, okay? Clear? Not joking, okay? You have to have that ability. Otherwise, you can't do math, okay? Have to grow that. With time, you have to grow that. You see something, you understand, okay? Bio people, you see something, you remember, okay? That's bio and maths, okay? For maths people, with time, you see something, you understand that all of a sudden. Bio people, you see something, you remember it after 10 years, okay? Okay. Is it clear? Is this clear? So for any angle, pay attention now. For any angle, sine squared theta plus cos squared theta is 1. For any angle, okay? Pay attention now, pay attention. For any angle, sine squared theta plus cos squared theta is going to be 1. Okay? Clear? Now, so this is 1. So what I get here is 12 squared 2, 12, 16 cos 60 plus, pay attention, stop talking, plus here this term becomes 16 squared into 1. This whole term becomes 16 squared into 1, which means 16, okay? So the final result becomes r squared equals 12 squared plus 2, 12, 16, pay attention, cos 60 plus 16 squared plus 16 squared. Got the idea? You solve this, you can get R. You know 12, 2, 12, 16, cos 60, 16. So just a bunch of numbers. You somehow solve this. Okay, it's a bunch of numbers. You somehow solve this, you would get the answer, okay? Clear? But now pay attention. This question was given not for the sake of this question, okay? What is this question number? I think 23, right? We are in question number 23. So now, in question 23, the problem was, pay attention, the problem was there were 2 vectors, okay, with 2 random values, 2 vectors with 2 random values and with a random angle. Now this was the only way out, right? This was the only way out. One vector is 12, other vector is 16. The angle between them was 60. Angle between them was 60. Okay? Clear? One vector was 12. One vector was 12. Other vector was 16. Angle between them was 60. So you got their resultant. You got their resultant like this, okay? You got their resultant like this. I'm going to explain this again. Pay attention. You got their resultant like this. 12 squared plus 2, 12, 16 cos 60 plus 16 squared, okay? So that's not all, okay? It's a card. Binal. Your card is here. Not from this class? There's no Binal here? Ah, he's there. Okay, pay attention now. Now, I mean, yes, we finished at a equation like this. Okay, pay attention now. We stopped at a equation like this. So why not create a general equation? Why not create a general equation? That means you have a vector p, pay attention. You have a vector p and a vector q. Okay? You have a vector p. You have a vector p and a vector q. You need to find their resultant, okay? You need to find their resultant. And the angle between them is, pay attention, theta. Okay? Why can't I write it as r squared equals, we got 12 squared. See, we got 12 squared and 16 squared. That means this squared plus this squared. That means, pay attention, p squared plus q squared. P squared plus q squared plus. Then I have 2, 12, 16. That means 2 PQ. 2 PQ. Then what? Then cos 60 means the angle between them, cos theta. Cos theta. So why not a general equation, right? Why not a general equation? So given a, given a vector, two vectors, P and Q, and the angle theta, okay? Pay attention, pay attention. When they give you the magnitude of two vectors, P and Q, and the angle theta, why can't I use this general equation? Instead of 12 and 16 and theta, instead of 12 and 16 and 60, if I use P, Q and theta, I would get this, right? I would get this, clear? Okay. So why not? So this is the next way we are going to solve vectors. Okay. Another way we can solve vectors. Instead of drawing diagrams, okay. Instead of drawing diagrams, given the value of the two vectors and the angle between them, that's all we need. Pay attention. Given the values of two vectors and the angle between them, okay, we can come up with a generally, we can find the value of r, right? The resultant. Got the idea? Clear? So this is a much convenient method. Yes, solving may be a bit difficult, with the values and all, but still getting the final answer, it's not hectic like drawing diagrams and applying all the theories, other theories, right? This is very straightforward, right? You just apply to the equation, okay? Just remember the equation and apply values here, okay? Clear? Let's write that as question 23. Go through the process. Go through the process. Then on the way you will come up with some questions. Then you can ask them. Then I can answer. Write this down. Yes, you can directly use that formula, okay? You don't need to solve and get that. Oh, you have combined class on 15th. Said that who you would give the recording. I mean, I asked him. Yeah. I can show you the voice note. The person who sent the cheat. Yes, you have combined maths on Monday, and I asked him, and he said that he would give the recording. Okay. I don't know who asked, but yes, he said that he would give the recording. And again, another question like, is it only a cricket match? No, okay, I am not going to repeat this again. It's not a cricket match. Only part of it is cricket match, okay? It's something happening parallelly to the other games. And the 27 batch people, as I said, they are going to play tap rugger. They are not under my supervision, and I'm not going to look at that side, but if you also need to die or something like that, you can join them. And believe me, they are really good at that, okay? They are not good at playing cricket. But the whole rugger team is there. And not only that, okay, there's a lot of Aurdu games too, okay? I know Aurdu is like it's way after Aurdu, but I mean, we have dodgeball, a bunch of Aurdu games and all, and a DJ towards the evening, okay? A DJ towards the evening. So try to join, okay? Anyways, you have nothing useful to do these days until results. And by then you may have the results with you. Okay? So you can celebrate your results too. I mean, O levels you get good results, right? It's the A levels you usually ruin. Okay. And if you don't have a team for something, like just be there on that day, we'll figure out the teams, okay? If you don't have teams, no worries, just be there on that day, we'll figure out the teams. Anyways, there's gonna be, all the teams gonna change in the morning. That's what usually happens. So no worries about that. So it's next Monday, okay? Next Monday, June 15th, morning 8. The ground is at Corte, so not far away. It's easy to access. Location and everything will be available in the group, okay? Location and everything will be available in the group. Sure. Okay, I mean, let's quickly derive the general equation too. The same way, try to derive the general equation. Go through the same process and derive the general equation for P, Q and theta. Well, use the same way and derive. Okay, pay attention. You have P, Q in this direction, and the angle between them is theta. So P, angle theta, then Q. Write this as X, this as Y. So quickly going through this. We can start sin theta, pay attention. Sin theta equals X over Q. Sin theta equals X over Q. Cos theta equals, pay attention, cos theta equals, sorry, sin theta is Y over Q. Pay attention everyone, stop talking. Pay attention. Sin theta equals Y over Q. Cos theta equals X over Q, right? X over Q. So Y equals Q sin theta. Y equals Q sin theta. X equals Q cos theta. Y equals Q sin theta. X equals Q cos theta, okay? Y equals Q sin theta, X equals Q cos theta. Then what is this whole length? It is P plus X, which means P plus Q cos theta. What is Y? Y is Q sin theta. Y is Q sin theta. Pay attention everyone, stop talking. Y is Q sin theta. Now R squared equals this P plus Q cos theta squared, R squared from this triangle. Pay attention, stop talking. R squared equals P plus Q cos theta squared plus Q sin theta squared. So we can write P squared plus 2PQ cos theta plus this squared Q squared cos squared theta. Stop talking everyone, last warning. Q squared cos squared theta plus you get what? Q squared sin squared theta. Then you get P squared plus 2PQ cos theta plus Q squared cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta is 1, right? Cos squared theta plus sin squared theta is 1. So you get P squared plus Q squared plus 2PQ cos theta. The same thing, okay? The same thing, same process, okay? And this is included in your tute, okay? This proof is there on your tute. This proof for the general equation is there on your tute. Pay attention. Pay attention. So that's not all, okay? That's not all. Did you understand this? The same as this question, okay? Same as this question, but with symbols, okay? Same as this question, but with symbols. Now, I mean, that won't be sufficient actually. Why? To actually know the final vector. Using this, I can find R. But what is R? What is R? That is the magnitude, right? What is R? That is the magnitude. Okay? Then, what about, like, what about the direction that I have to find, okay? Alpha. The direction alpha I have to find, okay? Clear? Pay attention. Stop talking. The direction alpha also I have to find, right? Clear? Why? I mean, knowing the magnitude of R won't be sufficient, right? You have to know the direction, which means alpha. So what can I do? What can I do? I can find tan alpha. How? You know, right? You have enough information to find tan alpha. What is tan alpha? Pay attention, stop talking. What is tan alpha? This one and this one, right? Tan alpha means this one divided by this one, right? This length divided by this length, clear? Okay. So it's going to be, what is this length? What is this length? Q sine theta. Q sine theta over P plus Q cos theta. Be silent, everyone. Be silent. I mean, I'm not the kind of person who get angry or, just give warnings. So I just remove you from the class, okay? Personally, I'm not a person who gets angry, okay? You can't make me angry because it's not because I'm really good. It's because, I'm not going to waste my peace of mind because of you, okay? So, I'm not the kind of person who gets angry, scold you and try to take you to the correct path. I just chase you out of the class, okay? I'm not into that getting angry and getting you to the correct path kind of thing, okay? So, when I ask you to be silent, because I'm not going to get angry and scold you and get you to the front. I'm not going to go through that process, okay? I can't get angry. So the only solution is to remove you from the class, okay? So what is tan alpha? Because it's going to disturb others. So my disability to get angry can't harm other students, right? So only solution would be removing you from the class, okay? You have to remember that from the next week, okay? So tan alpha. What is tan alpha? This one over this one, right? This one over this one, which means Q sine theta over this. P plus Q cos theta, okay? Q sin theta over P plus Q cos theta. So these two equations, okay? These two equations as the perfect solution rather than using diagrams, right? Here, these two act as the perfect solution, okay? These two act as the perfect solution rather than using diagrams. Especially for machines, actually, I mean, to computerize things, you need equations always, right? Later solving this would be a bit difficult, okay? See, now you have an equation. You have an equation to be solved, okay? Clear? You have an equation to be solved. But I mean, yes, that would be difficult, but it's a different problem, okay? Finding R is pretty straightforward now. You just write P squared plus Q squared plus 2PQ cos theta, right? P squared plus Q squared plus 2PQ cos theta. Clear? Then here you have tan alpha. Q sin theta over P plus Q cos theta. Clear? Got the idea? Okay? You should understand because I did that first as a question. Okay? Now we convert that into a general equation. Clear? And the best thing is you can directly use this general equation. Okay? Clear? You can directly use this general equation. No need to prove. Okay? Don't need a proof for that. Okay? Just write the general equation, then solve things. Okay? Clear? You can directly use this, and this is given in the tube. So if you like, you can write. If you like, you can write. Otherwise, I mean, not need. Just we have to try to do the questions. Okay? So just one theorem remaining for vectors. Okay? One theorem remaining for vectors, that is the parallelogram law. Okay, so the thing is, I'm not going to do any theory in the 6:30, 7:30 session because everyone isn't going to stay in that session. But as I always mention, you may have a higher capacity, you may be good at, you may like to go at a faster rate, you may like to do very difficult questions. So all these parts I'm going to shrink into this 6:30, 7:30 session. That means eventually it would be, maybe 6:38 or something like that in the future. But for now, it would be 6:30, 7:30. So in that session, what I'm going to do is, until now, we did things out of syllabus, Olympiad maths questions kind of stuff, revising mechanics. But now onwards, especially from next week, we can do difficult vectors questions in that 6:30, 7:30 session. So I'll be bringing questions from your term tests. There are very difficult questions sometimes in the term tests, okay? It entirely depends on how you deal with your school, okay? Here you go there, act like you know everything from classes. You would see questions that you would never imagine, okay? You go there, be humble, okay? Learn from teachers, you would get a balanced paper, okay? That's how it works, okay? So it entirely depends on how you deal with the school. So anyways, there are extremely difficult questions from in some term test papers, okay? So I'm going to bring those questions too. I'm going to bring everything mechanics, but very difficult questions in the 6:30 to 8 session. In that session, I'm going to move fast as always, do extremely difficult questions. You may not understand at the beginning, but eventually with time, you will try to understand them. Okay, that is the whole target. So from next week onwards, if possible, try to stay in the 6:30, 7:30 session. But if not, we are anyways providing that recording. So watch that, okay? We are anyways providing that recording. So watch the recording, okay? Watch the recording for sure. Then you can get a very good clarity about how to handle extremely difficult questions too. Okay? So like that, we have divided the class into 2 sections. Theory, I'm not moving fast, but 6:30 to 7:30, I'm moving really fast with extremely difficult questions, okay? So from next week onwards, try to be in that session. If not, go home and watch the recording, okay? Because from next week onwards, 6:30, 7:30 session will be in syllabus, not out of syllabus. From vectors, okay? Still, it will be difficult to understand, but still in syllabus, okay? Okay, so that is the target. So this equation, pay attention, you will get a good clarity next week because I'm going to do questions from this equation next week. What I need you to do is this live recording is anyways available in the group today. If you didn't understand this process, then try to understand, okay? Watch the recording and try to understand and come next week. Then next week we can do a bunch of questions from this and understand, okay? And yes, so there was someone asked for the timeline. There's no actual timeline. I mean, there would be the match in one side and all other games, especially for girls and all, and for guys also. There's a bunch of games. We'll go parallelly. Okay, so there's no actual timeline. We even don't know the timeline. So no actual plan, but I mean things will be informed in the group. But everyone try to join. Okay, on Monday and go through this and try to come to the next week session with a proper clarity of vector theorems, okay? Clear? So let's move to the 6:30, 7:30 session now. Online students, you can stay in the same link, okay? You can stay in the same link. And online students for tube delivery, contact our tube delivery number. Malay, provide the tube delivery number again. Tube delivery number will be available in the chat. So just come, you don't need a cricket team. If you are not in the group, make sure to talk with the invigilators and make sure you get added to the group. If you have to talk, if you need to talk with me, just come towards the stage and inform any concerns. So for any concerns, students online, this is our hotline, okay? Just put a message to the same hotline. Malik. Okay. So let's move forward. Today I'm not going to jump into vectors because only today I informed about doing vectors in this time too. Pay attention. Be silent, everyone. So today I'm not going to jump into vectors because today only I informed that in the 6:30, 7:30 session also we'll be doing vectors. So from next week onwards, the 6:30, 7:30 additional session would be entirely from whatever we do in the previous weeks, okay? From vectors, motion equations, motion graphs, everything from mechanics, okay? So for today also we'll be doing some additional points, discuss some mechanics parts that you asked, okay? Discuss some mechanics questions you asked, go through any mechanics related other stuff, do the difficult question tude 3. We are going to go through things like that for today. Then from next week onwards, it would be from the content we do in the class. From next week onwards, it would be from vectors. After like 2-3 weeks, we'll be doing motion. Then the questions would be from motion, okay? Term test questions, Olympiad questions from vectors. Then term test questions, Olympiad questions from motion, like that. So let's move forward. There's a, Mali, can I have a tute? Mali, a tute. So, yeah, tute, again, tute link, the drive link. You can find question 3 tute there, okay? Okay, check the drive link. Check the drive link. You can find the question tute 3 there. That is the tute that we are referring to today, okay? Pay attention. But there's 1 or 2 questions that you guys asked. So I'm going to first go through them. 1 or 2 mechanics related questions. One thing was about upthrust. One thing was about upthrust. Pay attention now. Stop talking, everyone. One thing was about upthrust. Okay. So in that case, I mean, do you know the upthrust? I mean, I'm just referring to some questions you asked in the chat and in the, like you inform me the areas you find difficult, okay? So you know that upthrust is V rho G, right? Do you know this? So we have to use this equation in some scenarios, okay? How do we get this equation? How do we get this equation? Pay attention. I'm going to discuss it this way. First, let's use the Archimedes theorem. What is Archimedes theorem? When an object is inside a liquid, okay, when an object is inside a liquid, submerged fully or partially, the upthrust is equal to the weight of displaced volume, right? So weight of displaced volume. So density equals mass over volume. So mass would be volume into density. Mass would be volume into density, clear? Pay attention. Mass would be volume into density. Then the weight of the displaced volume would be mg, right? Weight of the displaced volume would be mg. That is the weight, right? That's how we write the weight using mass, right? mg, clear? Which means what? M means V rho, then G, right? M means V rho, then we have G. So this is how we get the upthrust equation V rho G, okay? That's how we get the upthrust equation from V rho G, clear? So According to Archimedes' theorem, upthrust is equal to the weight of the displaced volume, right? Upthrust is equal to the weight of the displaced volume, which means V rho G, right? Which means V rho G. Is that clear? But I mean, this is actually entirely a result of pressure, okay? This is entirely a result of hydrostatic pressure. Did you understand this equation? So upthrust is a force acting upwards, okay? Upthrust is a force acting upwards, okay? Upthrust is always a force acting upwards, okay? So, I mean, this equation we can derive actually. This equation we can derive without Archimedes. How? How? Just get this system. For an example, let's take a cube. It's easy to prove this with a cube. This is a cube. Side length is A. Side length is A. So if this depth is H, this depth would be, it is H plus A. Clear? If this is H, this would be H plus A. Clear? Okay? If this is H, this would be H plus A. Okay? Now, what is the pressure force acting here? Pressure force is pressure into area, right? Force can be taken from pressure in, due to pressure, there will be a force F1. There would be a force F1. Okay? And due to pressure, there would be a force F2 upwards. Clear? And there would be pressure forces all around, right? But you know that the surrounding forces will cancel out each other, right? Why? If this is the object, if it has a force in this direction, it would have a similar force in this direction, right? If there's a force in this direction, it would have a similar force in this direction, right? So all the surrounding forces will cancel out each other, clear? Okay? All the surrounding forces will cancel out each other, clear? They would cancel out each other, okay? So there won't be any surrounding forces remaining on the system, okay? Everything would cancel out, okay? All the surrounding forces will cancel out. So what you have is the forces from the pressure here and the forces from the pressure here, clear? Okay? All you have is the forces from the pressure here and the forces from the pressure here. You understand that? Clear? All the surrounding forces due to pressure disappears. Why? They cancel out each other, okay? Equal and cancel out each other, okay? So, what is F1? What is F1? So, what is the pressure here? What is the pressure here? It is P1. What is the pressure here? It is P2. Okay? What is the pressure here? It is P1. What is the pressure here? It is P2. Okay? Clear? So now, P1 pressure can be written as H rho G, right? You know how to write the pressure, right? H rho G. Clear? Okay? Then what is the pressure P2? What is the pressure P2? Pressure P2, depth from here to here is H plus A, right? It's a cube. Depth from here to here is H plus A, okay? Depth from here to here is H plus A, clear? So H plus A rho G, pressure there is H plus A rho G. Is that clear? Okay? So what is the force F1 here? P1 into area, right? Pressure into area, you get the force, you know that, right? Why? Pressure equals force over area. So force equals pressure into area, clear? Force equals pressure into area, clear? So pressure is H rho G. Pressure is H rho G. What is the area here? A into A, right? Area here is A into A, clear? Area here is A into A, okay? A squared, okay? A squared, clear? So what is F2 here? What is F2 acting here? F2 acting here is P2 into this area. Pressure here into area, right? Pressure here into this area, clear? So pressure here is H plus A, rho G. What is the area here? A squared. A squared. Clear? Clear? So what is the force? Resultant force acting on this object. Resultant force would be F2 minus F1, right? Clear? Resultant force acting on this object would be F2 minus F1, right? F2 minus F1, clear? What is F2? This. H plus A, rho G, A squared, minus what is F1? H rho G, A squared. So you get rho G A squared out, because that is common. Rho G A squared common. Then you have H plus A here. You get rho G A squared out. Then you have H plus A here minus H here. Clear? You have H plus A here minus H here. Then H and H cancels out. Then you have what? Rho G, sorry, this is A squared, sorry. Common one is A squared. So here you have rho G A squared and another A, right? Here you have rho G A squared and here you have another A remaining. Clear? Which gives you rho G A cube. Rho G A cube. What is A cube? A cube is the volume of this guy, right? A cube is the volume of this guy, clear? So it is V rho G. V rho G, clear? So any equation we don't know how to derive, we don't know, okay? That is the theorem of physics, okay? Any equation we don't know how to derive, we actually don't know that, what is happening, okay? So Archimedes theorem or upthrust is not a very fancy force, so something suddenly appears out of nowhere. It's just the resultant force of pressure, okay? Resultant force created by pressure. Pressure creates a force downwards, pressure creates a force upwards, pressure creates forces from all the surrounding. Things cancel out. What you have is V rho G, okay? What you are left with V rho G, clear? So this is the actual Archimedes theorem, okay? So it's not something fancy or anything like that. It's not all of a sudden, okay, the object displays a certain volume, so because of that, all of a sudden a force appears. It's not like that. Actually, we don't need an Archimedes theorem, okay? We actually don't need an Archimedes theorem. It's just the resultant force created by pressure, okay? Clear? It's just a result of pressure, okay? So many students asked about this Archimedes theorem and all. Answer is you don't need Archimedes theorem, okay? Clear? Got the idea? So you don't need Archimedes theorem to derive V rho G. Even Archimedes derived it like this, so you don't need Archimedes theorem to derive this. You first get this, then you tell the Archimedes theorem, okay? Clear? Got the idea? Clear? So it's just the resultant of pressure forces, okay? Understood? Understood? I'll quickly go through this again because it was a very common question. Why V rho G? How this happens? So this is how it happens. Okay. That means here the depth is H. So the pressure at this level would be H rho G. So that H rho G pressure would create a force downwards, which is going to be H rho G into area. Area of this cube is A squared. So it's going to be H rho G into A squared, clear? H rho G into A squared, clear? Now what? Now what is the pressure at this level? Pressure at this level would be H plus A rho G, clear? Pressure at this level would be H plus A rho G, clear? Okay? Pressure at this level would be H plus A rho G, okay? Clear? So that pressure is going to create an upward force, right? Pressure always acts as a perpendicular force, right? Clear? So what would be the force due to the pressure here? Pressure into area, right? Which is H plus A rho G, H plus A rho G. That is the pressure at this level. H plus A, the total depth, H plus A. Rho G into area, which is A squared. H plus A rho G into A squared, clear? Then what would be the resultant force? You have F2 upwards, F1 downwards. So resultant would be F2 minus F1, right? Which is H plus A rho G A squared minus H rho G A squared. Rho G A squared common. You have H plus A minus H cancels out. You have rho G A cube. Rho G A cube. What is A cube? A cube is the volume of this guy, right? A cube means the volume of this guy. So you can replace A cube by V, then you get V rho G. So volume into density into G gives you the upthrust. So many questions were asked, why it's the density of the liquid? Now you have the answer. It's due to the pressure by the liquid. So rho is not the density of the object. Rho is the density of the liquid. Why? The pressure forces are created by the liquid, okay? Pressure forces are created by the liquid. So it should be the density of liquid. Got the idea? Got the idea? So this is how we get the equation V rho G. It's the result of pressure forces, okay? If you need, you can write these things down, because I mean, knowing upthrust is V rho G won't be enough, okay? That means you won't have any clarity, clear? You don't know if the equation changes a bit, then you know nothing, okay? Clear? Okay? So, that's the idea. Okay? Have to have a good clarity about whatever the equations you learned in O levels. You have to have a good clarity about that, okay? Clear? Without the proof and without knowing how it happens, okay, without the underlying theorem, that means there's nothing called upthrust. What you have is just pressure, okay? So pressure creates forces on any object submerged in it, okay? So just the result of that becomes upthrust. Without you having a proper idea about these equations you learned in O levels, you won't have a good clarity about how to use them later, okay? Clear? I mean, for an example, pay attention now. I mean, these things will be repeated in A levels, okay? So I'm going to go through all these proofs. There's a separate lesson, 1 month or 2 months we need for hydrostatics lesson. Again, 1 month or two we need for hydrodynamics lesson, okay? So there are entire lessons in A levels to learn about these things, okay? What I'm doing is just building common sense about what you learned in O levels. Pay attention. Now, I mean, everything would change. Like, assume that you have an object, you seal it, you just paste it, okay? Seal it to the bottom of something. Density of the liquid is rho, volume is V. What is the upthrust acting on this? You just seal it, clear? Entirely seal it, clear? Now what would be the upthrust acting on this object? When you only know the equation for the upthrust, you would tell what? Pay attention here. Pay attention, this is the important part. How things changes when you know the proof. You get an object, you absolutely seal it and paste it to the bottom. Okay? Now according to the equation you learned in O levels, it would be still the upthrust would be V rho G, right? Still the upthrust would be V rho G. Why? Volume into rho into G, right? But there's no actual upthrust, okay? Why? There's no water at the bottom now. There's no water at the bottom now. So there's no upward pressure force here. Okay? There's no water at the bottom now. Clear? So there's no upward pressure force at this level. It's only downward forces, okay? It's only downward forces, clear? Got the idea? Got the idea? It's going to be only downward forces. Nothing upward. Why? There's no water here. Clear? There's no water here. So there's no upward force. So the proof doesn't work properly now, right? You should have pressure forces from upward and pressure forces from downward, then the resultant becomes upthrust V rho G, right? But when you paste it here, seal it, maybe using concrete you seal it. Now there is no water here, right? if there is no water, there won't be any upward force. Clear? There won't be any upward force. Clear? Okay? So there won't be any upthrust acting on this. Clear? When you put your hand into you get a water bucket, okay? Get a bucket of water, put your hand, you would feel a force upward. But you push your hand, press it to the bottom of that bucket, such that there's no space between your hand and the bucket, you would feel that the water is not pushing your hand upward anymore. It just sticks to the basket. Why? When you stick your hand, okay, here like this, if you somehow remove all the water in between, now there is no that upward force component that was creating the upthrust. You only have a downward force from water. So it just push your hand further down. Clear? So when you just put your hand into water, you would feel water push your hand upwards. Why? Due to the upthrust. V rho G. Because you have a pressure from here, pressure from here. This pressure try to push your hand up. But you somehow move it down and press that against the basket. Now what happens? You press the hand against the basket. Now what happens? If you somehow remove the water in between the basket and your hand, there's no upward force anymore, because there's no water below your hand anymore. Only this downward force from these guys, clear? Which push your hand further down, clear? So you feel like your hand sticks to the bottom of the basket, clear? Because that upthrust equation disappears, okay? Archimedes doesn't work anymore, clear? See, so these kind of stuff you can't handle. You would just write V rho G. Okay, have to know the proof of any equation in order to use it under any condition, okay? Just knowing, okay, upthrust equals V rho G isn't sufficient, clear? You have to have a clarity about why V rho G, okay? Clear? That kind of a clarity we must have when we are doing science, okay? So if you need to write down anything, you can write. Okay. So, after that, let's go to the questions, dude. Let's go to the questions, dude 3. There were some questions you asked. I'm going to go through them. So, download the question dude 3. There's something called question dude 3 or questions 3 in the drive. Download that. I'll provide the drive link. It's available in the Zoom chat and in the YouTube live chat, both, the drive link. So, some other questions you asked. So, if it is floating, pay attention. If it is floating, stop talking everyone, pay attention. Now what? There's no upward force, right? There's no upward force. Clear? If it is floating like this, there's no upward force. And let's assume that height of h is here. So what is the pressure here? It is h rho g. It is h rho g. Clear? Now what? What is the upward force acting here? F. What is the upward force acting here? This pressure h rho g into area, right? Into this area. Clear? Then you get rho g into area into h. What is area into h? What is area into h? What is area into h? It is the submerged volume, right? See, that's what argument is said, right? Upthrust is, so AH is this submerged volume. That's why you get V rho g. That's why argument is said. Those are the questions you had. Why not the volume of the object? Why only the volume submerged? This is why. Now you don't have a downward force. No water here. Only this. So only this acts as the upthrust here, right? Now this along as the upthrust, right? There's no downward force. Only this acts as the upthrust. So it's going to be h rho g into this area, which means rho g ah. What is ah? This area into h means the submerged volume, right? Clear? That's how it becomes V rho g. That's why you get the submerged volume only, okay? That's why you get the submerged volume only. So nothing goes wrong when you know the fundamental, okay? Clear? It's not like, you live peacefully without the fundamental. You had a nice equation, now it's not there anymore. Now you have to think before applying the equation. Yes, it's a lot of work now, okay? But nothing goes wrong when you know the fundamental, okay? Clear? There's nothing to go wrong when you know the fundamental. The main problem in A-levels is students don't learn the fundamental. They have a bunch of theorems which they don't know how it appeared there. Now they just try to put the numbers into the equations. Now all of a sudden they are not getting the answer. Now they don't know what to do. Why? They don't know how the equation appeared. Okay? That's the most common issue in A-levels. Okay? That's why a lot of students get S and F. Students don't know how the equations appear. They know, okay, V rho g. Now they put V rho g. That's all. That's all they know. No, that's not how we work. Okay? Let's move forward. So there are some good questions. If I answer them, we'll keep doing upthrust. Is that okay? What about the atmospheric pressure? If there's atmospheric pressure, isn't that acting here? A good question. What happens if we consider the atmospheric pressure? Still nothing would go wrong. As I mentioned, when you use the fundamental, nothing would go wrong. Why? See, same object. Pay attention. Same object. Yes, let's assume now you have the atmospheric pressure P naught. Clear? Pay attention now. So what would be the force here? Atmospheric pressure into area, right? Force here would be atmospheric pressure into area. Now that same atmospheric pressure is felt here. So the pressure here would be, if this is H, not just H rho g now, it would be the pressure here P naught plus H rho g. Because the P naught pressure is felt here, right? The atmospheric pressure is felt here. So the pressure at this level won't be just H rho g, it would be P naught plus H rho g. So again, what is the upward force? The total pressure here, P naught plus H rho G into area. Clear? Now what is the upthrust? Difference of these two. Clear? Upthrust is difference of these two, which means P naught plus H rho G into area upward minus P naught A. Okay? So you get this P naught A plus HA rho G minus P naught A. Clear? So P naught A and P naught A cancels out. You still get HA rho G. Still get HA rho G. What is HA? Submerged volume. Height into area. Height into area means submerged volume. So still V rho G. Clear? Still V rho G. So when we use fundamentals, you can't come up with a situation where I get the wrong answer. Okay? You can keep asking questions the whole day, but when I use the fundamentals, we can't come up with a situation where we get the wrong answer. Okay? It cannot happen because we are dealing with fundamentals, not Archimedes. Okay? We don't even know why Archimedes said that. So, but we are not using Archimedes anymore. Okay? So when you use Archimedes V rho G, if someone asks you, okay, the atmospheric pressure will change this, right? It will create a force. Now we don't have an answer, right? Not anymore, clear? Okay? Not anymore. So when we are using fundamentals, you can't come up with a question that I get the wrong answer, okay? Clear? It won't happen because we are using the simplest form, okay? Just H rho G, okay? If you need, we can derive H rho G too, okay? That you know, right? You know the proof of H rho G, right? No? Yes, right? Some people know. I mean, some people know. I mean, so what creates pressure? Weight. What creates pressure? Weight. So the pressure here would be, the pressure here would be the force over area. Force over area. Which means whatever the weight above this over area. Pay attention. Which means whatever the weight above this over area, right? Whatever the weight above this over area. Force over area. And how do we get the weight? If the area is A, we get the weight by volume into density. Mass is taken by volume into density, right? Mass equals volume into density. And volume equals area into H. Volume equals area into H. Clear? So we get, right? So we get volume means AH. Volume means AH. Then multiply it by density, you get the mass. AH volume multiply by density, you get mass into G divided by A is H rho G, okay? So, pressure is just a result of liquid weight, okay? Pressure is just a result of liquid weight. Another question, what about gravitational acceleration? We can keep talking the whole day, okay? Uh, okay. Yeah. So you understand this? This all these proofs, okay? Clear? Now I mean, actually when something accelerates, pressure changes, upthrust changes. If this basket of water accelerates upward, everything changes. That cannot be taken from Viroji. That cannot be taken from Archimedes. That you have to start from what happens to the weight when it goes up. You start from here, then keep deriving, okay? Clear? Then there's a question, what about the atmospheric pressure? So you just add P naught A, later divide by A again, so you get P naught plus H rho G, right? Clear? So everything, I mean, returns to the same thing, okay? Clear? Everything returns to the same thing. I mean, this is the most fundamental. You start here, keep moving in this direction until you prove Archimedes, okay? So weight, you don't need a proof, right? Why weight is mg? Don't need a proof, okay? Yes, there's a proof there, okay? But actually, I mean, pay attention. Gravity haven't been understood yet, okay? Gravity haven't been understood yet well. The particle called graviton, which creates gravity, we haven't yet discovered. So yes, why mg? Nobody knows yet, okay? Why weight is mg? Nobody knows yet, okay? So it's a good question, can't answer. Okay, haven't discovered yet. Okay, that you can go and search these things. Just give it. So actually, this is what we call you knowing hydrostatics, okay? Not what you actually knew, okay? This is what we call knowing hydrostatics, okay? This is, I mean, now you know the actual meaning of whatever the hydrostatics theorems you learned in O levels, okay? Yes, how things happened, okay? So, question 2, let's go to question 7. Many students ask that. So from next week onwards, this will be from vectors, okay? Pay attention. A particle starts moving with an initial velocity u. With an initial velocity u. Accelerates to 3u. Starts at u, accelerates to 3u, then decelerate within time t2. This is t1, this is t2. This is the velocity time graph, right? Now pay attention, everyone. Pay attention, stop talking. This is the velocity time graph, right? Starting from u, within time t1 reach 3u, within time t2 stops. And t1, t2 is 5. That means this is how you write them, right? t1 over t2 is 5, right? Meaning of this is t1 over t2. The meaning of this is t1 over t2 is 5, okay? Clear? Next. This displacement given 5 kilometers. During the first part, we move 5 kilometers, which means 5,000 meters. Clear? They are asking the total displacement. Total displacement means the total area. So let's start with this. This area is given, the displacement of the first part, which means the area of the first part. Displacement means area of a velocity time graph, right? Displacement means area of a velocity time graph is given, right? Clear? Area of this velocity time graph is given, which is u plus 3u, u plus 3u over 2 into T1, area of a trapezoidal. This plus this into this over 2, right? It is given as equal to 5,000 meters. Okay. So you solve this, you get 2u T1 equals 5,000 when you solve this, which gives you ut1 equals 2,500. Gives ut1 equals 2,500. Okay, clear? So now with this you have ut1 equals 2,500. Now let's get this area. Now let's get this area, this one. What is that? It's a triangle, right? It's a triangle, okay? A triangle means you can get the area. So the displacement of that part, S2, would be the area of that part would be this into this over 2, right? This into this over 2, right? What is this? It is 3u, okay? This is 3u. This is 3u into T2, okay? 3u into T2 into half. That is the area of a triangle, right? Height 3u into T2 into half, okay? So now you have 3 over 2 ut2. You can write it as 3 over 2 u. T2 can be written as T1 over 5 using this, right? T2 can be written as T1 over 5 using this, clear? So you replace it there. T1 over 5, clear? So you would get ut1 over, sorry. So you would get 3 over 10, 3 over 10, 3 over 5 into 2, 10, ut1, which means 3 over 10. What is ut1? ut1 is 2,500, right? ut1 is 2,500. So you solve this, you would get 750. So the total displacement would be 5,000 here. Total displacement would be 5,000 here, 750 here, right? Total displacement is 5,000 here, 750 here, clear? So the total displacement 5,000 plus 750, 5,750 meters. 5,750 meters. Okay. Understood this? Yeah? Okay. So I mean, try to follow, the theorems used was what? The theorems used was of a velocity time graph, displacement means area, right? Pay attention. Of a velocity time graph, displacement means area, okay? So this area is given, it is 5,000. Clear? So use this to get the multiplication of UT1. Then you get this area. How? Height 3U, gap T2 into half, because it is a triangle. Then you replace T2 by T1 over 5 using this. They gave us the time, the connection between the time, okay? Then you get UT1 again. You have 3 over 10 and UT1 again. UT1 you replace by 2,500. Put it here, get the answer, okay? Okay, so I mean, some questions again I'll answer. I went through the question. So how does a ship floats? I mean, it's basic, how it happens. It just creates a larger volume than its weight, right? Entirely empty inside. Entirely empty inside, right? What a ship does is, it just creates a huge volume larger than its weight, right? So larger its volume, the larger the upthrust it can obtain. Pay attention. Larger the volume, larger the upthrust it can get, V rho G. Okay? If it is larger than the weight of the steel, okay? If this V rho G can handle mg, then it's going to float, right? Clear? Then there was a question about Titanic too. This question was there last week also. I mean, it's actually a chemistry question. Okay, you have to ask that from your chemistry teacher. It's actually what happened to Titanic was its ductile brittle transition. That means, those days people didn't have that clarity. I'll just take 2 minutes to explain that, because a good question actually. It's due to ductile brittle transition. That means, you know that steel is ductile. That means before breaking, it would change its shape, kind of elastic nature. If you before you break steel, it will change its shape, right? But what about glass? It just shatters without changing. That's the nature of ductile and brittle. Glass, before breaking, it doesn't show any signs. Ductile means before breaking, it shows signs, okay? That's the difference. So to create any mechanical structure, we use ductile stuff. Why? When it is close to a breaking point, we know that. Pay attention. Before a bridge breaks, we know that slowly shape changes. Then we know that something's going to happen. That doesn't happen with glass. It suddenly shatters. So those days, they didn't know about this. Steel at extreme cold temperatures turned into brittle. Okay? Nowadays steel is not like that. Nowadays steel is made in very complex mechanisms. It's not just steel. Steel turns into brittle at very negative temperatures. So when you enter a very negative temperature region, you are not strong anymore, okay? The steel ship is not strong anymore. It's not even ductile anymore. That's why it just breaks into two parts, okay? Clear? It doesn't have the same strength anymore. Kind of glass, okay? Otherwise, how the hell a steel structure can break into two parts, right? Clear? No, it is not steel anymore. That's why that difference they didn't know, okay? Nowadays, it's not going to happen because, I mean, the structures are very much complex, okay? So it's not steel anymore. It's a very complex structure. That's why I said it's chemistry. Okay. Do we have time for one more question? So, I mean, let's do it this way then. I mean, nowadays, I mean, until now, I have at optics session at 8. So that's why I can't go until it. But I mean, within 2-3 weeks, I'm going to shift it to 8:30. So then after that, we can move this session until 8, okay? So be ready for that. I mean, you're not tired, right? I mean, you can't feel tired. You're just sitting and listening. I mean, it's not something that you can get tired of, right? You just have to sit and listen. I'm the one who's teaching, okay? So no worries. So within like 2 weeks, let's move this session until 8, okay? For now, let's stop at 7:30. I mean, the time isn't enough to do very good questions. When it comes to mechanics, it takes sometimes 1 whole hour to finish one question. Okay, so that's the thing. So yeah, see you next Tuesday and also next Monday, okay? Bye.